Hey guys, Miss Lake here. I am bringing you the review highlights today. So I just wanted to kind of remind you of a few things on the review. There are wave questions on the review. There will be wave questions on the test. It is just an important topic. We will see it again later on, so we want to just kind of drive it home a little bit more. We've got the rational root theorem, which remember is that P, the Q, the P over Q. And again, that just gives us all possible roots that then we would use synthetic division to try to simplify and solve for all the roots. Then we've got where you're putting the roots back in to the factors to come back up with the polynomial. And remember that we've got that complex conjugate theorem that if we know that one, either it's a complex number or a radical, if we have the positive or what of it, we have to have the conjugate of it. So if you have a positive root 2, you're going to have a negative root 2. If you have a 3 plus I, you're going to have a 3 minus I. Okay, and remember we've got that trick about the sum product rule in order to help us write what those polynomials will be when we put those imaginary and radical roots back together. And then we've got kind of looking at the graph of our polynomials. And so that's going to be, we're going to go over just a few problems of each type, and I'll try to give you some hints and some tricks for you to make note of so that when you come to the test that you feel very prepared. So here we go. So the first thing that we're going to look at here is these wave problems. So I'm going to go and do my work over here. So I'm going to bring this 2x squared minus 5x plus 2 is greater than 14. Okay, now if we kind of look down, remember what are these all supposed to be like set, greater or equal to? They need to be equal to 0 because remember we're looking at that number line and we need to know if it's above 0 or less than 0. So the first thing we need to do here is move this 14 over. So I'm going to subtract the 14 from both sides and I end up with minus 12 is greater than 0. Okay, so now I need to factor. So remember when there's a coefficient in front, I have to multiply. 2 times negative 12, I have negative 24. And then my bottom number is negative 5. So what numbers multiply to negative 24 and combine to negative 5? Well, that would be negative 8 and positive 3. Okay, so now we're going to come down to our factors. I'm going to put my x minus 8 and x plus 3. Okay, now I hope that you remember and then realize that these factors are not going to multiply together to give me this. So remember, when you're multiplying or when you're factoring and there's a coefficient here, don't forget that your last step there is dividing each one of these terms by the coefficient. Now that simplifies to x minus 4. And then again, normally if we were just factoring, remember you would roll this 2 up to the coefficient. But since we're just trying to solve here, we can leave it as the 3 over 2 because we're going to move it over and solve in a second. So my critical points are 4 and negative 3 halves. Okay, so I'm going to come over here and draw my number line to do the wave. So I put my negative 3 halves and my 4 on the number line. Now I want to consider, are these open or closed points? I go back up here and I see that this is just a greater than, it's not an equal to, so they're going to be open points. Okay, now remember, when you're doing the wave, we always are starting on the right-hand side. Always, always, always. We start on the right side, and then we're just starting to determine whether we start on the top right or the bottom right. Okay, we go back and look. Remember, we're looking for a negative coefficient on our square term or leading coefficient if that's when we start on the bottom. But right here, I see it's a positive coefficient. So that means I'm starting on the top. So I'm going to start up here. I'm going to go through 4 and I'm going to go through my negative 3 halves. And then I'm looking for when my function is greater than 0. So I'm looking for the parts where it's above the line. So I see here and there, or where my function is above the axis there. So now I can come over here and I'm going to put it on my number line, negative 3 halves and 4. So again, they're open. And then I say, well, my shaded part is everything to the right of 4. So it's the same thing on my number line, everything greater than 4. Same thing, I'm less than the 3/2, so I'm going to shade on my number line everything less than 3/2. All right, so here's my graph. So now I'm going to write my set and interval notation. So remember, set is that x such that, and when we have these two graphs going away from each other, we're going to have two inequalities within our set notation. So we're going to say that our x's are less than -3/2, or my x is greater than 4. All right, and again, when it's split into two parts, we're going to have two intervals. So when it's pointing all the way to the left, we're starting at -infinity, and we go to that -3/2, and we stop. And then we think about, is it parentheses or brackets? And remember, if it doesn't go through, it's a parenthesis because it's getting right up close to it. And then we union, and then again, 4 is going to be in a parenthesis because it's not equal to, and then we're going to infinity. Okay, so a couple things that I just want to remind you about is, remember, you can factor these. Look here for a GCF sometimes is the first thing you need to do, is look for a GCF here. And then these bottom two, these are already in factored form for you. So a couple of reminders: whenever I have a parenthesis squared, don't forget that this root is what we call a double root. And remember, double roots, they bounce. So here I would see that this x is -3, and I would write that dr underneath it, because I know that there are two -3s, and then when I do my wave is going to bounce at that -3. Okay, and then we talk a lot about, where do we start? Do we start above, top right, or bottom right? So remember, we're either, if it's in polynomial form, we're looking for that leading coefficient. So if it's positive, we're starting on the top right. So again, positive, we'd start on the top right. Now, when it's in factored form, I'm looking at the signs on the x's. So this one's positive, this one's positive, this one's positive, and this one is positive. So when I multiplied, if I were to multiply all these back together, my leading coefficient would be positive. So here I'm going to start on the top right as well. But here I see, right here, I have a negative coefficient on my x. So if I multiplied all this back together, I would have a negative leading coefficient. So here we're going to start, and I'm just going to write you a little note over here. Start, wave, bottom right. Okay, everything always starts on the right, but it's when you have that negative coefficient on your x that you start on the bottom on the right-hand side. Okay, moving on to the next section. Okay, so these are our kind of our rational root theorem problems. Now, remember, some of these factors, so you may want to kind of look and see if there's some that factor. You don't have to use rational root theorem. Like right now, I can see this one I could factor, right? Because it's a trinomial, and trinomials can usually be factored into two binomials. And if I think about what factors multiply to 27 and combine to -12, I can think of some, right? That would be -9 and -3. So this one will factor, and then you'll have binomials, and they might factor again, because x to the fourth, you're going to have x to the squared. Okay, but let's look at one where we are going to have to do our P then Q and P over Q. So I'm going to go all the way down to this 10 because this is kind of our trickiest one, and so I want to do it with you. All right, so remember, P are all the factors of our constant. So I'm going to have plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. All right, and then Q is all the factors of the leading coefficient. So I have plus or minus 1 and plus or minus 3. All right, now I've got to do P over Q. So when I'm dividing all of them by 1, right, 1 divided by 1, 2 divided by 1, they're not going to change. So I'm going to start out with just saying I've got plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Now I have to divide each one of them by 3. So that's going to give me 4 more. So I'm going to have 1/3, I'm going to have 2/3, I'm going to have 4/3, and I'm going to have 8/3. All right, now guys, this is just a jumping off point for what I can use for my synthetic division. Now, notice that this is x to the fourth, right? We don't have tools to factor or simplify other than synthetic division for problems like that. So I am going to start with, let's see, I'm going to start with 1. Okay, now again, not all these will work, right? So I'm going to actually grab myself a pencil so that I can erase if I get it wrong. And I actually can't find a pencil close to me. Yeah, there's one. Okay, so I am going to use a pencil, and I recommend that you do a pencil as well because we often find that we're going to have to erase, right? So I've got 3, -16, and remember you're checking the order to make sure they don't skip. So I have 4, 3 x's, 2 x's, 1 x, so I don't need any placeholders with zeros. 22 and -8. All right, so I'm going to bring my 3 down. 1 times 3 is 3. That's -13. That's going to be -13. That gives me -2. 1 times -2 is -2. That's 20. Okay, so this isn't going to work, right? I'm going to end up with a remainder. Okay, so now, see, if we use a pencil, oh, isn't that lovely? All right, now I'm going to try my -1. All right, -1. So I'm going to bring down my 3. -1 times 3 is -3. So that gives me -19. -1 times -19 gives me +19. And that gives me 30. -1 times 30 is -30. That gives me -8. And -1 times -8 gives me +8. So boom, there's a 0. So I know that one of my x's is -1. All right, so now I am not going to go back up here. I have a new function. So I'm going to mark out that 0 because that was the remainder. So now, remember, this was 3x to the fourth. So now this is 3x cubed. But again, I don't really see that this would, if I put in my variables, would be able to group. So I'm going to just carry on with my synthetic division. Okay, so I'm going to draw my next little box here. I am going to start with, so let's see, I did positive and -1. So let's go to 2. So I'm going to start with 2. I'm going to bring my 3 straight down. 2 times 3 is, what is that, 6? -13. 2 times -13 is -26. That gives me 4. 2 times 4 is 8. Oh, beautiful. All right, we got rid of another one. So we know that x is equal to 2. Okay, now friends, this is a quadratic, so I should be able to factor it, or I could use quadratic formula. But remember, this was to the fourth, this was to the third, so this is 3x squared minus 13x plus 4. Now guys, if you want to keep doing synthetic division, you are more than welcome to. That is fine. If you see that you've got a quadratic and you want to plug it into quadratic formula, also totally fine. I am going to factor this. So again, when I have that leading coefficient, I have to multiply it by the constant. So 3 times 4 is 12. And then my bottom number is -13. So what multiplies to 12 and combines to -13 would be -12 and -1. So again, I put my x minus 12 and x minus 1. And then again, we say these are not the factors of this, right? X times x does not give me 3x. So remember, when we have that leading coefficient, this is that swing method. We have to divide by each one of our terms by the 3. So I get x minus 4. And again, if all we were doing is factoring, I would probably roll that 3 up into the coefficient there. But since I'm solving, it doesn't really matter. I can just leave it as 1/3. So then I have x is equal to 4 and x is equal to 1/3. So all of my x's together are -1. I'll put them in set notation here. So I have -1, 1/3, 2, and 4. Okay, and those are all my solutions. And again, going back to that fundamental theorem of algebra, right? I had a degree 4 and I have 4 roots, and that makes sense, right? So again, on some of these, like check and look and see, can you factor it? Can you factor it? Factoring sometimes is a great first step instead of doing synthetic division. Okay, moving on. Next, we're looking at how we're going to take, excuse me, the factors, excuse me, the factors and put them back into a polynomial. Excuse me. Sorry. All right, so I'm not going to do this whole one, but I just want to remind you that when we have integer coefficients, remember when they go back into our factors, they change signs, right? So x plus 3, we have x minus 2, and x minus 4. And all this, again, you can say is f of x, y, whatever. When you're writing an equation, it does say polynomial function, so I would go ahead and make that an f of x. Excuse me. All right, and so then all we have to do here is just FOIL these back together. Now, I want to jump down and I am going to look at number 14, okay? This has 2 radical roots, and remember we had that complex conjugate, which we also knew would affect our radicals as well. So remember, when I have positive root 5, I also have negative root 5. When I have minus root 2, I have 1 plus root 2. Okay, now I am going to use this sum product trick. Okay, so the first one I'm going to do is I'm going to say, okay, what's the sum and what's the product of my first 2 radicals? So I have the square root of 5 minus the square root of 5 is just 0. And then I have the square root of 5 times negative root 5, and I get negative 5. Okay, so if I follow the sum product, I have 0 for the sum, so that means there's no x term. So this would be x squared and then minus 5. All right, now let's do the sum product trick with our other 2. So sum product. So I'm going to take my 1 minus root 2 plus 1 plus root 2. We see that those roots are going to cancel out, and I have 2. And then we're going to multiply. 1 minus root 2 times 1 plus root 2. And here we're just foiling. So 1 times 1 is 1. My outer is positive root 2. My inner is negative root 2. And my last is minus 2. These we see are going to go away. And then 1 minus 2 is negative 1. Okay, so what does that make my polynomial? Well, x squared, and then it's minus the sum. So minus 2 times x. And then plus the product. Well, if the product is negative, then you just leave it negative. Now I just need to multiply these together, and then I will have my simplified polynomial. So x squared times x squared, so I'm going to go ahead and say this is f of x. X squared times x squared is x to the 4th. Then I'm going to distribute it to the second term. X squared times negative 2x is negative 2x to the 3rd. X squared times negative 1 minus x squared. Now I've taken the x squared to everything. Now I'm going to do the negative 5. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 2x is positive 10x. Negative 5 times negative 1 is positive 5. I see that I have these 2 like terms here, so that'll be the last thing I need to do to simplify. So I have x to the 4th minus 2x to the 3rd. When I combine a negative x squared and a negative 5x squared, I get negative 6x squared, and then I just bring down my 10x and my 5. And so this would be our simplified polynomial with these factors. Okay, and so again, over here, you're going to have you have an imaginary, so if you have this one, you've got to have its conjugate. And then you can use the sum product trick on those. All right, looking at graphs of polynomials. Okay, so I want to kind of write you a little note down here that I would include for yourself. So remember odd and even. Odd functions point opposite directions. Okay, so that the end of them, they were pointing opposite directions, and then even functions point in the same direction. All right, and then we're talking about positive and negative. So if it's positive, it is pointing up on the right side. And if it is negative, it points down on the right side. Okay, so let's look at this example right here. So I can see that this side is pointing down and this side is pointing up. So when they're pointing in opposite directions, that is an odd degree function. Okay, now I look at this side right here. On the right-hand side, it's pointing down, right? So if it's pointing down on the right-hand side, that's a reflection, and we know that it has a negative leading coefficient. Okay, so these are pretty straightforward, pretty easy. So again, the same direction, that would be even. We see it's pointing up on the right, so that would be positive. Okay, our last page. So this is sort of where we put it all together and look at the graphs. Okay, I am going to do this first one for us. So the first thing that we're going to do is we're going to find all the rational roots. Then we are going to kind of plot them on our graph. We're going to find our y-intercept as well, because that's going to only make our graph look a little bit more, be more accurate. Okay, so first we're going to start with trying to find our roots. So again, if I look at this, I say, okay, this sometimes a cubic function can be grouped, but this one I see that if I try to factor it like that, it's not going to work out. So I'm going to have to do my p, my q, then my p over q. Okay, so luckily this is a small one, right? So we have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. My coefficient on the leading term is just 1, so it's plus or minus 1. So my p over q is just my first one, first list of p. Okay, so again, I'm going to bust out my pencil because nothing is more frustrating than when we have to, you know, write it over and over and over again. So I'm going to write out my coefficients. So again, I check 3, 2, 1. So I don't need any placeholders. So my coefficient is 1, negative 1, negative 5, and 6. All right, so let's see. Let's start with 1. All right, we bring down that 1. 1 times 1 is 1. That's 0. 1 times 0 is 0. That's negative 5. I can see, sadly, it was close, but it doesn't quite get me there. All right, so I'm going to erase that. Okay, so let's try a negative 1. I bring my 1 straight down, my negative 1, that gives me negative 2. And I can multiply those, I get positive 2. When I bring that down, I get negative 3. Oh, still not quite there, right? All right, so I can mark the 1s off. I've tried those, so let's go to 2. So I know it's not my 1s. So I'm going to start with 2. So I'm going to bring that down 1. 2 times 1 is 2. Negative 1 plus 2 is 1. 2 times 1 is 2. Negative 3. 2 times negative 3. All right, we found one, right? So there's that, the 0 remainder. So we know that 2 is a factor. Okay, so now we look at this and we know that this is a quadratic equation. So this is x squared plus x minus 3. So I kind of start thinking about, okay, well, does this factor? Well, let's see, -3 multiplied to -3 and combined to 1. Oh, that is not going to factor. So I'm going to use quadratic formula, right? Because if it doesn't factor, then the only other way to get roots is by using quadratic formula. So I'm going to say x is equal to, and then remember, quadratic formula is that -b plus or minus square root of b squared minus 4ac all over 2a. So I'm going to go ahead and just write my numbers in. So here's my a, here's my b, here is my c. So I'm going to plug in x is equal to -b, so -1 plus or minus the square root b squared, that's 1 squared minus 4 times 1 times -3. Remember, that's a and c all over 2 times 1. So here I'm just simplifying. X is equal to -1 plus or minus the square root. That's 1 squared is 1. This is going to be -4 times 1 is -4 times -3 is +12. So 1 plus 12 is going to be 13 under there. And this is all over 2. All right, guys, so here are my other two roots, right? Because here's 1. And then I have 2 roots here, right? Because I have the -1 plus root 13 over 2. And then I have -1 minus root 13 over 2. So whenever I kind of need to know what those are as, so I could put it in my calculator. So, or sorry, put it on my graph. So I'm going to put it in my calculator real quick. And I see that the square root of 13 is 3.6. So I'm going to take a negative, I'm going to add a -1, and then I'm going to divide it by 2. So I get that this, our first one is 1.3. Okay, and then if I do -1, oops, sorry, I'm doing this in my calculator as I go, sorry, -1, and then I'm going to subtract my root 13, and then I'm going to divide it by 2, and I get that it is -2.3. Okay, so we needed to know what these were so we could put them on our number line, on our coordinate plane. And then remember, the other thing that when we're graphing these, we need to look for is what the y-intercept is. Okay, remember your y-intercept is when x is equal to 0. So this would be 0, this would be 0, this would be 0. And so it's always going to be that constant. So my y-intercept is the point 0.06. So now I have 4 points that I can plot and make this graph as accurate as possible. I have my y-intercept, so I'll start there. 1, 2, 3, 4, 5, 6. Go ahead and plot it. And then I've got my x-intercept of, whoa, sorry, lost my pencil. X-intercept of 2. An x-intercept of 1.3, so we're going to kind of put it a little over that 1. So that's going to be a real quick turnaround. And then we've got -2.3. So that's, again, going to be kind of in between 2 and 3, a little bit closer to -2. Okay, and then remember, this is very much like the wave. We're just going to put it on the actual graph. We see here we have a leading positive coefficient. So that means that this graph would be pointing up over here. So I'm going to start above, and I'm going to go through and through. I got to go all the way up to hit my 6 and then go back down. So this is what the graph of that function would look like. And now we're going to talk about end behavior. So when you're talking about end behavior, you're talking about 2 different things you're looking at. As x goes to positive infinity, what does your function do? And then as x goes to negative infinity, what does your function do? All right, so I kind of will usually write that all out, and then as I look this way on my graph, as x is increasing this way, what's my graph doing? it's increasing this way. So it is going also to positive infinity. When I look at what's happening on my graph as I go more towards the left, I see that my graph is pointing down. So as x goes in the negative direction to negative infinity, so does my function. It goes to negative infinity. Okay, so I hope this helps. Also, just kind of a reminder is that if you wanted to, you could put this on a wave before you actually put it on the graph. But I just kind of wanted to show you that, you can sort of see the wave right there. The only thing that we're doing a little bit different now is that we are paying attention to that y-axis, okay, and saying, well, where does it actually cross that y-axis? Okay, I hope this was helpful. Come back and make sure you follow up and ask your teacher if you have any more questions, and good luck on your test.